Hi, my name is HuynhNguyen. I am a PhD student at the University of Technology, Sydney. Today, I would like to present my recent research on deep learning techniques for enhancing the accuracy of air pollutant forecast. As air pollutant is a main problem causing from the industries and urbanization, especially in the big city like Hanoi, Ho Chi Minh City, and here in Sydney, we are also suffering huge problems from the air pollutants. And it is estimated that nearly 2,000 Australians die per year. Or the government spend nearly $24 billion in order to support for healthcare and patients who are suffering from the air pollutant sicknesses. And the government has also spent millions of dollars for building the air monitoring stations over the whole countries. And they also using the wireless sensor network in order to monitor the real-time information, especially the air pollutants level in the suburban and surrounding the city. And the government has also dedicated to provide the forecastic values from their physical based models such as chemical transport model or CTM. But these models require high intensive computing efforts and time in order to produce the uh, approximate forecastic values. Um, with the high amount of data available in from monitoring station, with sensor networks and numerical modeling software, um, I apply deep neural network in order to extract the hidden features from the abundant data in order to improve the forecast qualities. In my research, the long short-term memory variance of recurrent neural network is the main core technology using in my research. This is a state of the art for predicting the sequential data like time series, natural language processing, and inside each cell of the LSTM models, it has nonlinear gates that control the flow of information inside going in and out of the models. And finally, it has robustness in order to overcome the gradient problems such as vanishing or exploiting issues usually encountering during training the neural network. In my model, I use mainly two main variables. The first one is the CTM, or the value forecasted from the chemical transport models that has also included the meteorological features. And the second one is the observation, that are the values collected from the air quality monitoring station in order to train the models with the past features or historical data as the input, and the output or the target feature is the next step of the real observation. I also incorporate Bayesian neural network in my research because it has robustness in quantify the uncertainties of the models. And the main target of this technique is to calculate the posterior of the parameters of the models given the inputs to the models. But the inference of Bayesian technique is quite complicated to the neural networks because of nonlinear relationship of the parameters. So we apply the variational inference techniques, which aims to approximate the posterior distribution of the model parameters. And the optimization function using here is the Kuhn-Bachleibler diversion, where we can approximate the posterior distribution. And I combine two techniques into a hybrid model in order to formulate the prediction of the air pollutants. As you can see here, the preliminary results of the hybrid models provide us not only the point-wise estimation, but also the whole distribution for each time step, so that we can infer the forecastic values with a high probability. So you can see here the gaps between the prediction and the real observation is close in comparison with the baseline models. Here I use two baseline models. The first one is the CTM baseline model, and the second one is the simple stack LSTM models with our Bayesian inference. And from the distribution, we can infer the confidence intervals where we can apply to the decision-making system. I also applied the models to experiment for different dataset, 28, 2013, 2021, for two type of pollutants. The first one is ozone, the second one is PM2.5, and I use the root mean square error as the evaluation matrix. So you can see here the graphs present the performance of the model prediction uh, comparison with the two other baseline model, the LSTM and the CTM. So you can see the all of the cases, the hybrid model can improve the significantly the prediction performance, and it can reach up to 72.8% for ozone and 40.4% for PM2.5 in comparison with the physical-based model CTM forecast. So in conclusion, the LST model can be robust in time series forecast, and BNN Bayesian inference can quantify the uncertainty of the model prediction, and so that the combination between two techniques can enhance the performance of the forecast for time series as air pollutants. So this technique can also apply in different domains, such as for weather forecast or for IoT-based monitoring systems. And we can develop two calibration system or the imputation techniques for the local wireless sensor network and monitoring stations. And finally, this model can improve the prediction not only for the seasonal data like ozone, but also for stochastic pattern features like particulate matters, as shown in my preliminary results. And as you can see that I use only two variables. The first one is CTM, and the second one is the observation for the inputs, so that it can reduce the times and resources for training, predicting, and processing on the variables. Thank you for your listening.